This is code.org. Let's see what we're doing. Investigate and modify. Run the program to observe the results. Then experiment with the program by making the following modifications. Change one line at a time. All right, we know the drill. Look at the loop reverse and recursive reverse methods in the list processor.java class. What similarities? All right. So here's loop reverse. Let me shrink that. So similarities I see right away are start and end, right? They both have a conditional statement. A while loop, it does have a conditional in that it is running on a condition, right? As long as start is less than end, our loop continues to repeat itself. And when it is not, it stops. If also being a conditional statement. Now, I notice these conditions are flipped possibly, but interesting. So, okay. What other similarities do I see? Looks like they both have these temps, numbers start, numbers end. The else. Interesting. And they are both incrementing, adding one to start and subtracting one from end. All right. In my console, comment out the call to loop reverse method and add the line list recursive blah, blah, blah. Okay. Can I just control C this guy? And actually, let me first hit run. But, all right, now let's do this. Comment out. Hey, the same result. Then run the program. What do you notice about what is printed? It is, yes, it's identical. What is the purpose of the return statement in the recursive method? Well, so guys, this is new to us to some degree, using return in this way. All return does here is end our method. So we're not even returning a value. Notice that this is a void method. All we're doing is ending it. So we're saying, all right, we're done. Just return. Just stop running. At this point, the program this method is over. And it returns to wherever it was ran from or called. Change the return statement to system print done. Then run and observe. Okay. So we're going to do that. Interesting. So this return statement I don't think has much of an impact anyways because it has an else and then the method ends regardless. Let's see. Done. And then it prints. Why do you think this is needed? So if we look at this recursive method, guys, notice this method is calling itself. It's kind of trippy because what's happening is we run this thing and we say whatever, and then we paste in our number array the starting index and the ending index, right? And then if the start is greater than the end, up, over, we're done. We don't want to keep running this thing. However, and this is similar to a loop, otherwise, if the start isn't greater than or equal to the end, we do want to run the method again. And what do? We say temp is going to be equal to numbers start. So whatever number we're currently at, numbers start is going to be equal to numbers end because we're flip-flopping them, right? And then whatever used to be numbers end now needs to be what was numbers start. Well, we save numbers start at temp, so we save it there. We then, and this is the tricky part, call recursive reverse again. So we go zoop. It's a method calling itself, and we do the same thing. This is functioning very much like our loop. The return statement is what is used once start is no longer greater than end. We return, and we are done calling this method. Otherwise, we would just keep going through and calling it over and over. Return means you're totally done. You don't need to keep calling it. All right, change the body of the recursive to... Okay, change the body. Your code hit a wall, an exception while it was running. Why do you think it happened? Well, our method never ends. This is an infinite loop. We're just calling it and calling it and calling it. So recursive method can be tricky in recursive calls. I'm excited to dig into this though. It's a really powerful thing to learn about and to make our programs more efficient, better, fancier. Yeah, onward.